I'm just going to talk about the two rules related to the biconditional. Now, to understand these, in a way, you simply have to understand what a conjunction is. So, the rule for the conjunction, ampersand elimination, allows us to go from a conjunction to its left conjunct, or to go from a conjunction to its right conjunct. In other words, if a conjunction's true, its left conjunct's true. If a conjunction's true, its right conjunct's true. So this is a truth-preserving rule, obviously. And ampersand introduction means that if we have any two sentences, we can put them together in a conjunction. And that will always be truth-preserving, because if P is true and if Q is true, then both P and Q is true. And of course, we can put them in the other order and it doesn't make any difference. So that's a truth-preserving rule. That would never take you from true to false. So those two rules are, from a conjunction you can take out either conjunct, and from any two sentences you can put them together as a conjunction. Well, the biconditional is nothing more than a conjunction of two conditionals. And at least in the elimination rule, double arrow elimination, it behaves exactly like the conjunction. So double arrow elimination allows you to go from a biconditional between two sentences to a conditional from the left to right sentence. So you go from P if and only if Q to if P then Q. And equally, you can go from the biconditional P if and only if Q to if Q then P. And if you think of the biconditional as a conjunction of two conditionals, one going in one direction and one going in the other, but between the two sentences, then obviously the conjunction of the two conditionals, if P then Q and if Q then P, is just the biconditional. And so you should be able to take out, if you like, one of the conjuncts here. So double arrow elimination allows you to take the left to right conditional out of the biconditional, or the right to left conditional out of the biconditional. And then correspondingly, the rule to introduce a biconditional, double arrow introduction. Well, to prove a biconditional, you have to have available as true, or is assumed to be true, both the conditionals. So if you have if P then Q and if Q then P, then you can conclude P if and only if Q. And equally, if you have if P then Q and if Q then P, you can conclude Q if and only if P. What's different from conjunction introduction, ampersand introduction here is, there you can take any two sentences that you already have and put them together to form a conjunction. Here you can't take any two sentences you already have, even any two conditionals you already have. They have to be a special pair. You have to have one conditional, well, you have to have this relation, the relation between the antecedent of one conditional and the consequent of the other, and the relation between the consequent of one conditional and the antecedent of the other. So long as you have two conditionals, where the antecedent of the first is the consequent of the second, and the consequent of the first is the antecedent of the second, any two conditionals like that can be put together to form a biconditional. So the biconditional is the conjunction of two conditionals where The antecedent of one is the consequent of the second, and the consequent of the first is the antecedent of the second. And any two conditionals like that can be put together to form the biconditional, and the biconditional can also be taken apart into the two conditionals of which it's made up. So these rules really parallel the rules for ampersand introduction and ampersand elimination for the conjunction, and that's because the biconditional is just a conjunction of two conditionals. So, two rules for the ampersand conjunction, ampersand elimination, ampersand introduction. Two rules for the disjunction, wedge introduction, wedge elimination. Two rules for the biconditional, double arrow elimination, double arrow introduction. And I've also talked already about arrow elimination for the conditional. That leaves two rules to be discussed. One is how to prove a conditional. Well, obviously if you have a biconditional, you can prove a conditional that's one either the left or the right. But there are many cases in which, although we can't prove the consequent of a conditional, we can prove if we had its antecedent, we could prove its consequent. And that is the secret to the rule arrow introduction, which is sometimes called conditional proof or hypothetical proof. So that's another rule that we still have to learn about. And then the last rule of all is reductio ad absurdum, which is related in a way to the negation as a logical operator. And that is the most powerful rule that we have, but it's also, like conditional proof, like arrow introduction, it's one that requires us to use a slightly different technique. In particular, what we have to do is to make temporary extra assumptions in our proof. And that's the next thing that I'll talk about.